Here, high knowledge of strength of material cannot cover soil also, because when we study strength of material, every material should be covered in that. That is what the kind of impression that we carry. But why the soil is separately studied? There are a number of reasons. It is because soil has no unique Young's modulus or Poisson's ratio. Because you know that strength of material, the basic parameter that we find or define is E, the Young's modulus, and Poisson's ratio. You name a particular material like a steel or aluminium, we know what is Young's modulus of that, we know what is Poisson's ratio, and because of that, you know how to calculate under the action of forces. The stresses are developed because of stresses, what kind of strains are developed, volume increase, decrease, all those things can be studied, and then even we'll be knowing what is the safe magnitude of the load that can be put on a variety of materials like steel, how much load it can take maximum. Wood, if you take, even wood can be studied that way, right? But in case of soil, what happens is for every uh, you can say for every foot the soil continuously changes, if not drastically, but there will be change. It is not the same, right? The soil has got variety of types depending upon its origin, depending upon its composition. There's variety of soils are there, so it is not uniform soil all on earth surface. Why earth surface? For a country, if you take, or a state, if you take, even a district, if you take, different parts of the areas will be having a different property. Because of that, you cannot study it as one material. It has to be studied as a separate, separate theory has to be established to understand the soil behavior. That's why there is a different soil, a different subject by name, soil mechanics. Next is it undergoes considerable volume change unlike other materials. Okay, when we put a load on steel or concrete, there won't be much of a volume change. So in this case, soil, there is a lot of volume change is possible. Because of that only there rises settlement. Settlement is nothing but volume change. So how the soil behaves, how the change in volume occurs, it is a time dependent phenomenon. Not that you put a load and suddenly there will be decrease in the volume and settlement takes place. You have observed that the settlements will be taking a lot of time, and gradually the settlements occur in a span of years of time. We have seen leaning tower of Pisa, that tilt has occurred for years together, right? It is not a one day phenomenon. Even if you have seen some buildings in the beginning, when the new buildings are erected, they may be very fine and then good to look at, but if there is some mistake in foundation or foundation soil, you might have seen some cracks widen up in millimeters and centimeters, right? Ultimately, if the purpose for which the soil, the building is constructed is not working out, then you have to remove the building and reconstruct. So we should know behavior of the soil, and it is a typical character of soil that under the application of a load it settles, or there will be change in volume. This settlement or the change in volume is time dependent phenomenon. Because of that, it is difficult. You don't know whether it is a week long period or a year long period for settlement. So because of these major three reasons, it is not covered under strength of material, right? It has to be studied with a different kind of a theory. Some more reasons here why soil is difficult to study. It has got porosity, right? When you study a solid material like steel or a concrete, hardly it has got any porosity, or almost no porosity. But this is porous because on the soil, when you pour the water goes inside. That is the proof that it has got a lot of pores inside. So fluids can flow through the soil. So this porosity brings a characteristic feature to soil. It has voids where water and air will be present. Sometimes water is present, sometimes air is present, sometimes water is simply present or it is flowing. So all those conditions we study soil. Next is soil is polyphasic in the sense it can be present in solid state or it can be present in plastic state, or even muddy water can be called as a soil. Because percentage of soil is more, it can be called as soil. Plastic state, you know that whenever clay models are made, or clay as a clay, when we use it, we love to use it and make use of it, right, for variety of purpose. So people can exhibit their creativity and art through those clay, or even idols or statues can be made out of clay, right? And even at some stages like bricks and all, it is in solid state, right? So soil can be in solid state, in plastic state, or in liquid state. So we should know a variety of theories to handle this. So that's why there is a separate theory that is developed. Next difficulty of soil is it is particulate. So it can behave as an isolated particle or as a lump of soil. So when the particles are bigger, it is particulate in the sense every particle behaves almost independently. When there is a mass, it will be different. But in case of finer particles, that is when the particle size becomes small, the soil lump will be acting as one rather than a single particle. And whether it is small or big, the soil consists of particles. Right? Of course, we'll be classifying the soil according to their sizes also. We'll be studying that in detail. But uh, what is important is it cannot be like uh, fluid like water, or it cannot be like solid like steel. So it is a different characteristic that it is made up of particles, whether it is big or small. Next is soil is heterogeneous. That is no uniformity with respect to size and constituent material. Means the size of the particles are different, fine. The constituent material, that it can be made up of a variety of things because it is a mixture. As we have defined in earlier case, it can be a mixture of organic and inorganic. Inorganic itself, there can be a variety of things which have come from different sources. So nothing is uniform. It is heterogenic, right? And as I told you, if you move for a few meters from a point, the soil that is existing may be different. Another few meters, if you go, you may find totally different kind of material. Vertically also, the material which is present on the at a depth of let us say 1 meter may be different, and then if you go deeper, the soil may be different that we generally see. So it is not uniform one, homogeneous one, right? It is heterogeneous. Next is it is anisotropic. It can have properties of different magnitude in different directions at the same point in soil space. That is anisotropic. Means if you take a point in a soil inside below the ground level, and then if you study, for example, permeability, means the rate at which the water is allowed in horizontal direction and in vertical direction, they may not be same. So we call this property as anisotropic. If the properties are same in all the directions at a particular point, we say that it is isotropic. Now here soil may not behave as an isotropic material, it is anisotropic material. So whenever theory is developed, you have to take into account this kind of change in behavior. Application of theory, if it is uniform and isotropic, it is easy. But in such circumstances, that is when there is a soil with heterogeneous properties and anisotropic properties, you have to develop a different theory altogether. Next is the behavior of soil is non-linear. Linear, you know that it is stress and strain. If there are linear, plot is straight line, and then slope is called Young's modulus. But here, right from the beginning, if you plot stress strain curve, it may be stress strain curve. It will not be straight. It will be continuously dropping, right? So you will not be able to find one slope where we can call it as Young's modulus. So it is non-linear. Now pressure level dependent. Since if you apply more and more pressure, uh, it will be behaving in a different manner, right? The pressure level defines how the soil should behave. Strain level dependent. If at all there is a change in size and shape, that is settlement, right? In the beginning, the settlement is quite faster, right? The strain is faster. But after some time, so though the load is same, right, the strain may be quite less, or the rate at which the settlement is occurring will not be much in later stages of construction. So it is a strain level dependent and pressure level dependent. It is strain rate dependent also, in the sense, simplest example is you want to construct a road. So what do is you dump a soil and then compact it, or by rolling or something like that, right? While rolling, if the rolling is done faster, means faster in the sense, what I mean is a dynamic loading by heating continuously, or you have a mechanism where there is a dynamic load, then the compaction is faster or settlement is faster. That itself, if you do it a normal rolling, then the settlement or compaction will not be that fast, right? So at what strain rate the soil is being changed, that will be affecting soil properties. So because of all these reasons, that it is porous, polyphasic, particulate, heterogeneous, anisotropic, non-linearity, pressure, strain, and then stress dependent, time dependent. This makes soil a difficult material to study. Soil is of course a difficult material, but it is an interesting material too, because you can just see here there are a variety of colors with which the soil comes. Maybe gray, this is not gray, beige it is, but there are soils with gray colors, warm gray, reddish gray, and then here the brown content is increasing. Here it has become almost black cotton soil. You got red soil, right? You got yellow soil, you got gray soil. So all these colors are because of chemical content they carry in parent rock. So soil is interesting because it has got a variety of colors. Soil is sensitive for disturbance. As we have seen in earlier slide, right? If you are putting a different type of load, whether it is a dynamic load or static load, the soil will be behaving in a different manner. It behaves as if it has got memory. Means you will see that in the chapter of consolidation and even in strength of material. I mean, not shear strength. There you will see that the soil will be behaving as if it has got memory, and as the time passes the properties change. It behaves like a thixotropic material, means as time passes the soil behaves in a different manner altogether. So that's why it will be interesting to study this particular material. Okay, thank you.